What are existence theorems?
An existence theorem is one that has a statement beginning with there exist, s. Or, more generally, for all x, y, there exist, s. Existence theorems are presented in several ways, including showing the exact formulas for the solution, describing in their proofs iteration processes how to approach the problem, and by simply deducing the solutions without showing any methods as to how it was determined. Many mathematicians do not believe in existence theorems, stating that any theorems in which entities cannot be constructed are worthless. Other mathematicians cite the existence of such theorems but prefer to use tried and true theorems that offer specific proven methods.
What was the Roman calendar?
The first Roman calendar, according to legend, appeared when Rome was founded around 750 BCE. When it actually started is still up for discussion. But the calendar was based on the complexity of the solar-lunar cycles. At first, the calendar had 10 months, starting in March. January and February were added as the calendar was modified. Politics entered into the determination of this calendar, too, with certain officials deciding to add days whenever they desired, and even what to name certain months.
What is measurement?
Measurement refers to the methods used to determine length, volume, distance, mass, weight, or some other quantity or dimension. Each measurement is defined by specific units, such as inches and centimeters for length, or pounds and kilograms for weight. Such measurements are an integral part of our world, from their importance in travel and trade, to weather forecasting and engineering a bridge.
Why are the terms cardinal and ordinal sometimes confused in mathematics?
Cardinal and ordinal numbers are sometimes confused because they have two distinct mathematical definitions. The cardinal numbers in the numbering system should not be confused with cardinal numbers in set theory, in which any method of counting sets using a cardinal number gives the same result. Likewise, the ordinal numbers in arithmetic should not be confused with ordinal numbers in set theory. Such numbers, often called ordinals for short, are the order type of a well-ordered set. They are divided into two types, finite and transfinite ordinals. For more about sets, ordinals, and cardinal numbers, see Foundations of Mathematics.
What was François Vite's contribution to geometry?
French mathematician François Vite, or Franciscus Vitae, in Latin, 1540 to 1603. Although thought of as the founder of modern algebra, also introduced a connection between algebra, geometry, and trigonometry. He also included trigonometric tables in his Canon Mathematicus. 1571, along with the theory behind their construction. For more about Vite, see History of Mathematics and Algebra.
What is mean sea level?
Mean sea level, MSL, is the average water level, height of the sea, for all stages of a tide. Locally, MSL is measured by tidal gauges at one or more points over a given period of time. The resulting numbers average out wind waves and other periodic changes in sea level. The overall values of a MSL are measured with respect to level marks on land called benchmarks. Thus, scientists know a true change in MSL is either from a change in sea level from, for example, possible global warming effects, or changes in the gauge's height on land, such as in the case of local uplift. There is also a more mathematically intensive way to determine the MSL. To a geodesist, a person who studies the shape of the Earth, MSL is determined by comparing measured heights of the global mean sea surface, MSS, above a level reference surface called a geoid, a mathematical model of an ellipsoid shape that approximates Earth's mean sea level. This comparison is done because the Earth does not have a geometrically perfect shape. For example, the Atlantic Ocean north of the Gulf Stream is about 3.3 feet, 1 meter, lower than it is farther south. The MSS is not a level surface, thanks to such factors as currents created by wind, as well as atmospheric cooling and heating that cause differences in sea levels around the world. But interestingly enough, it never differs from the global geoid by more than about 6.56 feet, 2 meters.
What is accuracy in measurement?
Accuracy in measurement is based on relative error and number of significant digits. Relative error is the absolute error divided by the calculated, or estimated, value. For example, if a person expects to spend $10 per week at the local espresso bar, but he or she actually spends $12.50, the absolute error is 12.50. 10.00 equals 2.50, the relative error then becomes 2.50/10 equals 0.25. To find out the percent, multiply by 100, or 0.25x 100 equals 25% of the original estimate. Significant digits refers to a certain decimal place that determines the amount of rounding off to take place in the measurement. In most cases, this means that there are more numbers to the right of the decimal point. But beware. Accuracy in measurement does not mean the actual measurement taken was accurate. It only means that if there are a large number of significant digits, or if the relative error is low, the measurement is more accurate.
Who was M. C. Escher?
Moritz Cornelius Escher, 1898 to 1972. Was a Dutch painter famous for his mixing of art and mathematical concepts. He had no formal math training past secondary school, but he was, and still is, admired by mathematicians for his amazing visualizations of mathematical principles. Escher's interest in mathematical patterns began around 1936, after viewing the Alhambra Palace's collection of Islamic art, see above. He was fascinated with structures represented in plane and projective geometry both. Euclidean and non-Euclidean geometry. For more information, see geometry and trigonometry. Not only using the geometry of space, but also the logic of space. For example, he used the idea of tessellations, or arrangements of closed shapes, usually polygons or similar regular shapes, like those used on a tiled walkway, that cover the entire plane without overlaps or gaps. Not only did he use regular tessellation shapes, but also irregular ones, making the shapes change and interact with each other. He also made many of his amazing patterns by taking a basic pattern and either distorting it and or applying what geometers call reflections, translations, and rotations. For many other mathematical patterns, he used regular solids, Platonic solids, and visual aspects of topology in his work. For more about Platonic solids, see geometry and trigonometry.
What are the addition rules of probability?
In probability theory, the addition rule is used to determine the probability of events A or B occurring. The notation is most commonly seen in terms of sets, P, A U B, equals P, A, plus P, B, P, AB, in which P, A, represents the probability that event A will occur, P, B, represents the probability that event B will occur, and P, A U B, is translated as the probability that event A or event B will occur. For example, if we wanted to find the probability of drawing a queen, A, or a diamond, B, from a card deck in a single draw, and since we know there are 4 queens and 13 diamond cards in the deck of 52, the equation and resulting probability becomes 4 50-seconds plus 13 50-seconds. 1 50-second equals 16 50-seconds. The 1 50-second is derived by multiplying 4 50-seconds x 13 50-seconds. But there are also rules of addition for mutually exclusive and independent events. For mutually exclusive events, or events that can't occur together, the addition rule reduces to P, A U B, equals P, A, plus P, B. For independent events, or those that have no influence on each other, the addition rule reduces to P, A U B, equals P, A, plus P, B, P, A, P, B.
How are absolute and relative humidity determined?
Like many other facets of meteorology, mathematics comes in handy when determining absolute and relative humidities. The absolute humidity is the mass of water vapor divided by the mass of dry air in a specific volume of air at a specific temperature. In this instance, the warmer the air, the more water vapor it contains. On the other hand, relative humidity, RH, is the ratio of the absolute humidity to the highest possible absolute humidity, which in turn depends on the current air temperature. Mathematically, RH is often defined as the ratio of the water vapor density, mass per unit volume, to the saturation water vapor density, usually expressed as a percent. The equation for relative humidity is RH equals actual water vapor density / vapor saturation density x 100%. More commonly, RH is thought of as the amount of water vapor in the air at a given temperature in comparison to the amount that the air could contain at the same temperature. For example, if an area is experiencing 100% relative humidity, that usually means the air is saturated with, can't hold any more, water vapor.
What is the Gregorian calendar?
By 1582 the discrepancies in the Julian calendar were not interfering with timekeeping, but they were beginning to infringe on dates of the Church's ecclesiastical holidays. The powerful Catholic Church was not amused. Pope Gregory XIII, on the advice of several of his astronomers, decided to reposition days, striking out the excess 10 days that had accumulated on the then present-day calendar. Thus, October 4, 1582, was followed by October 15, 1582, to fix the extra days problem. The Pope made sure that the last year of each century would be a leap year, but only when it is exactly divisible by 400. That means that 3 leap years are suppressed every 4 centuries. For example, 1900 was not a leap year, but 2000 was a leap year. Today, the Gregorian calendar rules state that every year divisible by 4 is a leap year, except for years that are both divisible by 100 and not divisible by 400. Some countries eliminated the 10 extra days, starting fresh with the Gregorian calendar. But not everyone agreed with the new calendar, especially those who distrusted and disliked the Catholic Church. Eventually, by 1700 those who had not changed their calendars had collected too many extra days. In 1752, the English Parliament decreed that 11 days would be omitted from the month of September. England and its American colonies began to follow the Gregorian calendar, with most other countries following close behind. It is now the standard calendar used around the world.
What is an indirect proof?
Direct proofs begin with a true statement and then proceed to prove that a conclusion is true. But there is also a method called the indirect proof in which indirect reasoning is used. First, assume that the conclusion is false, then show that this assumption leads to a contradiction of the hypothesis or some other accepted fact, such as a postulate or theorem. Therefore, if the assumption is proved false, the conclusion has been proved indirectly to be true.
What is a polar coordinate system?
In effect, a polar coordinate system wraps a two-dimensional, Euclidean, coordinate system onto the surface of a sphere. For more information about coordinate systems, see geometry and trigonometry. A polar coordinate system examines a point in space defined in terms of its position and distance on a sphere with a unit radius. The center of the sphere is considered the origin. The first two coordinates are the longitude and latitude on the sphere, the third coordinate defines the distance of the point from the center of the sphere, the values of latitude, longitude, and height. In polar coordinates, it's easy to see on a globe of our own planet latitude ranges from +90 to -90, longitude ranges from -180 to +180, and height ranges from 0 to infinity.
What is Avogadro's number?
Avogadro's number, also called Avogadro's constant or Avogadro's figure, was determined by Italian physicist Lorenzo Romano Amadeo Carlo Avogadro, Count of Quarenna and Cerreto. 1776 to 1856, who was also the first one to use the term molecule in chemistry. It represents the number of elementary entities, such as atoms, molecules, or formula units. In a mole of any chemical substance, a mole is approximately 6.02214199 x 1023 atoms. According to the most recent number from the National Institute of Standards and Technology. To translate even further, a mole is the molecular weight of a substance in grams. 1 mole is the amount of a substance that contains Avogadro's number. For example, the number of carbon atoms in 12 grams of the substance carbon-12 is equal to 1 mole.
What is mathematical physics?
Mathematical physics uses the concepts of statistical mechanics and quantum field theory. But it is not the same as theoretical physics. Mathematical physics studies physics on a more abstract and meticulous level. Theoretical physics entails less mathematics than mathematical physics and has more to do with experimental physics. But like many fields of science, defining mathematical physics is not easy. For example, still another definition of modern mathematical physics states that it entails all areas of mathematics other than classical mathematical physics.
What are ordinal and cardinal numbers?
In common, arithmetic terms, cardinal numbers are those that express amounts. They are also used in simple counting or to answer the question of quantity, how many. They can be nouns, try counting to 10, as pronouns, 10 were discovered, or adjectives, 10 cats. Specifically, the term is from the Latin cardine, meaning stem or hinge, referring to the most important or principal numbers, with others depending, hinging, on those numbers. We are most familiar with the cardinal numbers as our counting numbers, or the Hindu-Arabic numeration system 1, 2, 3, and so on. Ordinal numbers are much different. In common, arithmetic terms, ordinal numbers are adjectives that describe the numerical position of an object, such as first, second, third, and so on. They are used to show the order of succession for objects, second chair, names, second month, or periods of time, second century. Note that cardinal and ordinal numbers are easily divided. For example, in the Hindu-Arabic numeration system, the cardinal numbers may be read as ordinals, such as May 10th being read as May 10th. Such differences are even harder to distinguish when it comes to Roman numerals. Most of the time, these numerals are considered cardinal numbers, I, 2, 3, etc. But they can also be ordinal numbers in certain contexts, such as Henry VIII, Henry VIII. Roman numerals can even contain ordinal suffixes, such as the IXTH dynasty.
What are the rules for combining logarithms?
There are certain rules for combining logarithms. In the following cases, let A be a positive number that does not equal 0, n is a real number, and u and v are positive real numbers. Logarithmic rule 1, loga, uv, equals loga, u, plus loga, v. Logarithmic rule 2, loga, u/v, equals loga, u, loga, v. And logarithmic rule 3, loga, u, equals n loga, u. This can be expressed as follows, in rule 1. Multiplication inside the log is turned into addition outside the log, and vice versa, in rule 2. Division inside the log is turned into subtraction outside the log, and vice versa, and in rule 3. An exponent on anything inside the log can be moved to the front of the log as a multiplier, and vice versa. But remember, these rules only apply if the bases are the same. For example, because the bases are not the same in loga, u, plus log, v, this expression can't be simplified.
What other way did Archimedes use to find the area of a circle?
The Greek mathematician Archimedes, c. 287 to 212 BCE, Hellenic, also found a way to determine the area of a circle similar to the Chinese comb. A method he first recorded in his work, Measurement of a Circle, c. 225 BCE. He also used a sequence of wedges to determine the area of a circle, as the number of wedges or triangles inside the circle increased toward infinity, they became infinitely thin. By giving each small triangle a base, b, a line connecting the points where the wedges touched the circle's circumference, he determined that the area was 1/2 times the radius r times the base, summed over all the infinitesimal triangles, or sum, 1/2, rb. Because they all had the same height, that was factored out. Thus, the area became 1/2 r sum b equals 1/2 rc, with c being the circumference, or the sum of the bases b of all the triangles, since the bases make up what is perceived as the circle's circumference.
What are exponents?
Exponents are actually shorthand for multiplications and represent the number of times a number is being multiplied, called the base. For example, 9x9 equals 92, or 9x9x9 equals 93. Another term for this process is raising to a power, in which the exponent, a number as a superscript, is the power. For example, 93 is 9 raised to the third power. It is also easier to write larger numbers with exponents. For instance, instead of writing xxxx, we can write x4. For more information about exponents, see algebra.
How is the Pythagorean theorem connected to right triangles?
The Pythagorean theorem deals with right triangles, simply stated. The sum of the squares of the legs equals the square of the hypotenuse, longest side. The converse of the Pythagorean theorem is also true, if the sum of the squares of a triangle's two sides equals the square of the longest side, then the triangle is a right triangle. For an illustration of the Pythagorean theorem, see History of Mathematics.
How do we interpret dimensions in everyday life?
We are all familiar with dimensions around us, although we may not be aware of them. Most people are familiar with the ideas of two, such as a drawing on paper, and three-dimensional objects, ordinary objects, including an apple or a car, exist in three-dimensional space, but there are others as well. Zero dimension can be thought of as a point in space. One dimension can be visualized by a line or a curve in space. Another way of understanding one dimension is with time. Something we think of as consisting of only now, before, and after. Because the before and after, regardless of whether they are long or short, are actually extensions. Time becomes similar to a line, as in timeline, or a one-dimensional object. Two dimensions are defined by two coordinates in space, such as a rectangle. One of the most obvious two-dimensional objects we see all around us are paintings and photographs, although they represent a three-dimensional object. Even this page you are reading can be considered a two-dimensional object. Though strictly speaking, the thickness of the paper gives it a third dimension. Three dimensions are considered the space we occupy, as three dimensions gives everything around us depth. Our binocular vision allows us to see depth, things in three dimensions. Which is why everything becomes flat or two-dimensional when we view the world through just one eye. One can also conceive of four or more dimensions, but there are few common examples. Most hyperdimensional aspects are used by mathematicians, various scientists, and even economists. They need such dimensional analysis for their complex mathematics, such as for modeling weather patterns or the ups and downs of the stock market.
What are deduction and induction, and how are they used in mathematics?
Deduction in logic is when conclusions are drawn from premises and syllogisms. For more information on these terms, see above. In this instance, a deduction is a form of inference or reasoning such that the conclusion is true if the premises are true, or, based on general principles, particular facts and relationships are derived. Deductive logic also means the process of proving true statements, theorems. Within an axiomatic system, if the system is valid, all of the derived theorems are considered valid. For example, if it is known that all dogs have 4 legs and Spot is a dog, we logically deduce that Spot has 4 legs. Other examples of deductive reasoning include Aristotle's syllogisms. Induction is a term usually used in cases concerning probability, in which the conclusion can be false even when the premises are true. In contrast to deduction, the premise provides grounds for the conclusion, but it does not necessitate it. Inductive logic generates correct conclusions based on observation or data. But note that not all inductive logic leads to correct generalizations, making the validity of many such arguments probabilistic or iffy by nature. One can see how both these processes work in the scientific world, especially in the scientific method in which general principles are inferred from certain facts. For example, by observation of events, induction, and from principles already developed. Deduction, new hypotheses are formulated. Hypotheses are then tested by applications, and as the results satisfy the conditions of the hypotheses, laws are developed by induction. Future laws are then often developed, many of them determined by deduction.
What is a frequency table?
A frequency table is a way of summarizing data. In particular, it is a way of displaying how entities, such as scores, number of people, etc., are divided into intervals, and of counting the number of entities in each interval.
What are axioms and postulates?
These two words are often treated as the same, in fact. Some mathematicians consider the word axiom a slightly archaic synonym for postulate. Although both are considered to be a proposition, statement. That is true without proof, there are subtle differences. An axiom in mathematics refers to a general statement that is true without proof. And it is often related to equality. Such as two things equal to the same thing are equal to each other, and those related to operations. They should also be consistent. It should not be possible to deduce any contradictory statements from the axiom. A postulate is also a proposition, statement, that is true without proof. But it deals with a specific subject matter, such as the properties of geometric figures. Thus, it is not as general as an axiom. For example, Euclidean geometry is based on the 5 postulates known, of course, as Euclid's postulates. See below, for more about Euclid, see History of Mathematics and Geometry and Trigonometry.
What are theorems, corollaries, and lemmas?
In mathematics and logic, a theorem is a statement demonstrated to be true by accepted mathematical operations and arguments. In general, a theorem is usually based on some general principle that makes it part of a larger theory. It differs from an axiom in that a proof is required for its acceptance. Some of the more well-known theorems are named after their discoverers, such as the Pythagorean theorem, involving right triangles, and Fermat's last theorem. It is interesting to note that American Richard Feynman, 1918 to 1988, one of the most brilliant physicists of the 20th century, stated that any theorem, no matter how difficult to prove in the first place, is viewed as trivial by mathematicians once it has been proved. Thus, according to Feynman, there are only 2 types of mathematical objects: trivial ones and those that have not yet been proved. A corollary is a theorem that has been proved in only a few steps from an established theorem, or one that follows as a direct consequence of another theorem or axiom. Finally, a lemma is a theorem proved as a preliminary or intermediate step in the proof of another more basic theorem, or, it is a brief theorem used to prove a larger theorem.
What are the basic symbols used to operate on sets?
When set theory founder George Cantor developed the symbols for sets, he used a single horizontal overbar to denote a set with no structure besides order, thus, it represented the order type of the set. A double bar meant that there was no order from the set, which is also called the cardinal number of the set, see below.
What is the Hertzsprung-Russell diagram?
The Hertzsprung-Russell diagram is a two-dimensional graph of the mathematical relationship between the absolute magnitude, luminosity, stellar classification, and surface temperature of star Sol, resulting in a diagram of the stellar life cycle. It was plotted by Danish astronomer Ejnar Hertzsprung. 187311967, in 1911, and independently by American astronomer Henry Norris Russell, 1877 to 1957, in 1913.
How are the principles of ratio, proportion, and symmetry applied to architecture?
The definition of a ratio is a comparison by division of two quantities expressed as the same unit measurement. For example, a building that is 200 feet wide and 100 feet tall has a ratio of 2:1, 200:100, between its width and height. It is also seen as the fraction 1/2. Such a relationship was understood as far back as ancient Greece and Rome. When people used mathematics to give structure and aesthetics to buildings. This is especially important in architecture, in which building design is based on complex mathematical ratios. Proportion is an equation stating that two ratios are equal. Every proportion has four terms, with the first and fourth terms being the extremes. The second and third terms are called the means. In each proportion, the product of the means equals the product of the extremes. The Greeks and Romans often used proportions in their buildings and other structural designs. The Roman architect Vitruvius was also instrumental in praising the virtues of proportion and symmetry in architecture. For more about Vitruvius, see above. During the Renaissance, architects applied proportion and other mathematical formulas to produce aesthetically pleasing buildings, beauty that still holds true today. Although there are other types of symmetry, the most common is line symmetry, in which a line divides an object, line, or other structure into two equal halves. An example in nature would be the wings of a butterfly. If a line of symmetry is drawn, each point on one side of the line has a corresponding point on the opposite side of the line. If you connect these 2 points, the line is perpendicular to the line of symmetry. There is a more mathematical way of defining symmetry. 2 points are symmetric about a line if the line is the perpendicular bisector of the segment joining the 2 points. Symmetry was used by ancient, and modern architects to maintain visual and sometimes structural balance of a building or structure.
Are there differences between independent and dependent variables in mathematics and statistics?
Yes, there are subtle differences between these two types of variables in mathematics and statistics. In mathematics, independent variables are those whose value determines the value of other variables. In statistics, they are a manipulated variable in an experiment or study whose presence or degree determines the change in the dependent variable. Dependent variables in mathematics are those variables whose value is determined by an independent variable. In statistics, they are the observed variables in an experiment or study, whose changes are determined by the presence or degree of one or more independent variables. For more information about variables in statistics, see Applied Mathematics.
What is a null or empty set?
A null or empty set contains no elements. An empty set is considered to be a subset of every other set. The opposite of an empty set is, logically, a non-empty set, or one that is not empty. The notations for empty set are and 0, but not, as it is sometimes written in texts. Interestingly enough, an empty set is considered to be both open and closed for any set X.
How can the accuracy of a mathematical model be determined?
There is usually one good way to determine the accuracy of a mathematical model. Once a set of equations has been built and solved, if the data generated by the equations agree or come close to the real data collected from the system, then we can determine its accuracy. In fact, the set of equations and models are only valid as long as the two sets of data are close. If a model result leads to conclusions that are not close to the real-world scenario, then the equations are further modified to correct for the discrepancies as much as possible. For example, in weather prognostication, meteorologists use various numerical models to make long-term predictions of weather systems. For more information about models and weather prediction, see Math in the Natural Sciences. It is interesting to see how meteorologists use a combination of several of the weather models to forecast the weather in certain spots around the United States and the world, mainly because no weather forecasting model has all the right answers. Every day, researchers are tweaking their respective weather models based on more collected data, in hopes of eventually understanding our weather a bit better.
What is the Titius-Bode law?
The Titius-Bode law was developed by German astronomer Johann Daniel Titius, 1729 to 1796. Titius's idea was brought to the forefront by German astronomer Johann Elert Bode, 1747 to 1826. The law actually represents a simple mathematical rule that allows one to determine the distances, also called the semi-major axis, of the planets in astronomical units. It is determined using the equation A equals 0.4 plus 0.3, 2n, in which n is an integer and a is the astronomical unit. Interestingly enough, most of the planets and even the asteroids in the asteroid belt adhere to the law. The only exception is Neptune, the second to last planet in our solar system.
What are proofs and theorems in geometry?
Proofs are extremely important to geometry. Similar to other divisions of mathematics, proofs are defined as sequences of justified conclusions used to prove the validity of an if-then statement. For more information about postulates, theorems, and undefined terms, see Foundations of Mathematics. There are essentially 5 steps in showing that any proof is a good proof. State the theorem to be proved, list what information is available. Draw an illustration, if possible, to represent the information, state what is to be proved. Finally, develop a system of deductive reasoning, especially concentrating on statements that are accepted to be true. Along with the true statements, add any necessary undefined terms. In geometry, in order to prove a theorem, you need to use definitions, properties, rules, undefined terms, postulates, and possibly other theorems, and like hyperlinking to other text with internet links. Such theorems can be used throughout geometry, and other mathematics, in the proofs of other new, more difficult theorems.
What are some first-order differential equations?
A first-order differential equation is one involving the unknown function y, its derivative y, and the variable x. As seen above, these types of equations are usually referred to as explicit differential equations. There are several types of first-order differential equations, including separable, Bernoulli, linear, and homogeneous. For explanations of the last two, see below.
What were the problems with the Egyptian number system?
The Egyptian number system had several problems. The most obvious being that it was not written with certain arithmetic calculations in mind. Similar to Roman numerals, Egyptian numbers could be used for addition and subtraction, but not for simple multiplication and division. All was not lost, however. as the Egyptians devised a way to do multiplication and division that involved addition. Multiplying and dividing by 10 was easy with hieroglyphics, just replace each symbol in the given number by the sign for the next higher order. To multiply and divide by any other factor, Egyptians devised the tabulations based on the 2 times tables, or a sequence of duplications.
Are random numbers generated by a computer truly random?
For most general purposes, random numbers generated by a computer can be considered random. But in reality, because a computer follows a set of rules in any program, the numbers generated are not truly random. In order for a sequence or specific numbers to be truly random, they must not follow any sort of rules. That's something to think about the next time you purchase a computer-generated random numbers lottery ticket.
What is a statistic and a sample statistic?
A statistic is the measure of the items in a random sample. A sample statistic is meant to give information about a specific population feature, or parameter. For example, if a sample mean is gathered for a set of data, that would provide information about the overall population mean.
What are some of the statistics used in baseball?
There are numerous statistics used in baseball, including batting and pitching statistics. Batting statistics can be divided into several numbers. The batting average, is the number of hits a player makes divided by the number of times at bat. It does not include walks or sacrifice hits. The runs batted in, RBI, is the number of runners who scored on a player's hit. Base on balls, or sacrifice. The on-base plus sluggage, OPS, is a good measure of a hitter's ability. This statistic combines getting on base percentage, or OBP, and advancing runners, slugging percentage, or SLG. It is also more accurate thanks to the adjustment 1.2x OBP and SLG, which compensates for the fact that SLG has a wider range than OBP. Pitching statistics include the ERA and WHIP. The earned run average, ERA, is the earned runs times the innings in a game. Most commonly 9, divided by the innings pitched. The walks plus hits per inning pitched, WHIP, records the bases on balls, walks, plus hits divided by innings pitched. It's a good way to measure the approximate number of walks and hits a pitcher allows in each inning that he pitches. It then compares that amount to other pitchers to formulate a pitcher's index.
What are the concepts of convergent and divergent sequences?
Convergent and divergent sequences are based on the limit of a sequence. A convergent sequence, the one most commonly worked on in calculus, means that one mathematical sequence gets close to another and eventually approaches a limit. Convergence can also apply to curves, functions, or series. This is seen visually when a curve approaches the x or y axis but does not quite reach it.
What are the solutions relative to differential equations?
There are three types of solutions when discussing differential equations. General solution. This includes the solutions obtained from integration of the differential equations. In particular, the general solution of an nth-order ordinary differential equation has n arbitrary constants from integrating n times. Singular solution. Solutions that can't be expressed by the general solutions. Particular solution. Solutions obtained from giving specific values to the arbitrary constants in the general solution.
What are the foundations of mathematics?
The foundations of mathematics include how to formulate and analyze the language. You have to speak the right mathematical language to make meaningful mathematical statements, axioms. A statement accepted as true without proof, and developing logical methods in all mathematical studies. The most basic mathematical concepts in the foundations include numbers, shapes, sets, functions, algorithms, axioms, definitions, and proofs.
What are open and closed sets?
Formally, an open set is one in which every element in the set has a neighbor in the set or does not include its boundary. A closed set is one that does include a boundary of a set, or one where some elements have neighbors not in the set.
How can one visualize Pascal's triangle using algebra?
One way of looking at Pascal's triangle is through its connection to algebra. For example, expand, or remove the brackets around, the expression, 1 plus x, 2 equals, 1 plus x, 1 plus x equals 1 plus 2x plus x2. The same can be done with a cube, for example, 1 plus x, 3 equals, 1 plus x, 1 plus x, 1 plus x, equals, 1 plus x. 1 plus 2x plus x2, equals 1 plus 3x plus 3x2 plus x3, and even the expression, 1 plus x, 4, which equals 1 plus 4x plus 6x2 plus 4x3 plus x4. The coefficients The numbers in front of the x's in the results are the connection. For the first example, the coefficients are 1, 2, 1, for the second one, 1, 3, 3, 1, and for the last expression, the coefficients are 1, 4, 6, 4, 1. These, of course, are the third, fourth, and fifth lines from Pascal's triangle.
What is the integral calculus?
The integral calculus is the part of the calculus that deals with integrals, both the integral as the limit of a sum and the integral as the antiderivative of a function. See below for more information. In general, the integral calculus is the limit of a sum of elements in which the number of the elements increase without bound, while the size of the elements diminishes. It is also considered the second most important kind of limit in the calculus. The first being limits in association with derivatives. It was originally developed by using polygons to approximate areas of geometrically shaped objects such as circles.
What is numerical analysis?
Numerical analysis is a branch of applied mathematics that studies certain specialized techniques for solving mathematical problems. It employs mathematical axioms, theorems, and proofs, and often uses empirical results to further analyze or examine new methods.
How does one convert latitude and longitude to degrees from readings containing degrees, minutes, and seconds?
It takes simple mathematics to convert the degrees, minutes, and seconds of latitudes and longitudes into degrees only. It helps to know that there are 60 seconds in 1 minute, and 60 minutes in 1 degree. Therefore, to translate 65 degrees 45 minutes 36, also written as 65 hours 45 minutes and 36 seconds, south latitude into degrees, you would do the following calculation: minus 65 degrees, south makes the number negative. Plus 45 minutes x, 1 degree slash 60, plus 36 seconds x, 1 slash 60, x, 1 degree slash 60, equals minus 65.76 degrees latitude.
How did certain ancient cultures count large numbers?
It is not surprising that one of the earliest ways to count was the most obvious, using the hands. And because these counting machines were based on 5 digits on each hand. Most cultures invented numbering systems using base 10. Today, we call these base numbers or base of a number system the numbers that determine place values. For more information on base numbers, see Math Basics. However, not every group chose 10. Some cultures chose the number 12, or base 12. The Mayans, Aztecs, Basques, and Celts chose base 20, adding the 10 digits of the feet. Still others, such as the Sumerians and Babylonians, used base 60 for reasons not yet well understood. The numbering systems based on 10, or 12, 20, or 60 started when people needed to represent large numbers using the smallest set of symbols. In order to do this, one particular set would be given a special role. A regular sequence of numbers would then be related to the chosen set. One can think of this as steps to various floors of a building in which the steps are the various numbers. The steps to the first floor are part of the first order units. The steps to the second floor are the second order units, and so on. In today's most common units, base 10. The first order units are the numbers 1 through 9, the second order units are 10 through 19, and so on.
What are formulas and equations in chemistry?
Formulas and equations in chemistry don't always mean the same as in mathematics. Formulas in chemistry are representations of a chemical compound using symbols for the elements and subscripts for the number of atoms present. For example, the chemical formula for water is H2O, in which there are two atoms of hydrogen, H, bonded to an atom of oxygen, O. The subscript 2 indicates that there are two atoms of hydrogen in the molecule. If there is no subscript number, as with the oxygen, O, a subscript of 1 is implied. Remember, not all compounds are molecular, for example, NaCl or sodium chloride. Regular table salt is called an ionic compound. In these cases, the formula shows the proportion of the atoms of each element making up the compound. There are other types of formulas in chemistry, but this is the most familiar. Equations in chemistry also differ from those in mathematics. Chemical equations represent the reaction relationship between two or more chemical compounds along with the products of the chemical reaction. For example, the chemical equation 2H2 plus O2 $2H2O is the reaction of hydrogen with oxygen to form water. The arrow indicates the direction of the reaction toward the product. The reactants, or the substances that react, are hydrogen and oxygen. There is also a methodology in writing chemical equations. Simply put, first determine the reactants and outcome, next determine the formula for each substance, and finally, balance the equation.
Why do so many philosophers study the foundations of mathematics?
There are three underlying reasons why philosophers often study the foundations of mathematics. First, these foundations have always been a part of scientific thought. with the abstract nature of mathematical objects offering unusual and often unique philosophical quandaries. Second, the subject offers a high level of technical sophistication, allowing philosophers to develop connections between models and patterns, laying the groundwork for many other sciences. And finally, the foundations of mathematics provides ways for philosophers and mathematicians to try out general philosophical doctrines in a specific scientific context.
What is a polygon?
The word polygon means many angles, Greek poly for many, gonies for angle. It is a closed figure in a plane made up of line segments, straight with no curves, that intersect only at their vertices, endpoints. In other words, no sides, lines, can touch each other except at endpoints. A polygon has the same number of sides as it has vertices.
What are astronomy and astrophysics?
Astronomy is the study of matter in outer space. It is usually considered a branch of physics. But because it encompasses, literally, an astronomical number of subjects, everything from the study of a star's surface to the end of the universe, it is often considered a field of its own. Astrophysics is a branch of astronomy dealing with the physics of celestial bodies and the universe as a whole. It deals with problems that range from the structure, distribution, evolution, and interaction of stars and galaxies to the orbital mechanics of a near-Earth asteroid.
What are some of the statistics used in baseball?
There are numerous statistics used in baseball, including batting and pitching statistics. Batting statistics can be divided into several numbers. The batting average, is the number of hits a player makes divided by the number of times at bat. It does not include walks or sacrifice hits. The runs batted in, RBI, is the number of runners who scored on a player's hit. Base on balls, or sacrifice. The on-base plus sluggage, OPS, is a good measure of a hitter's ability. This statistic combines getting on base percentage, or OBP, and advancing runners, slugging percentage, or SLG. It is also more accurate thanks to the adjustment 1.2x OBP and SLG, which compensates for the fact that SLG has a wider range than OBP. Pitching statistics include the ERA and WHIP. The earned run average, ERA, is the earned runs times the innings in a game. Most commonly 9, divided by the innings pitched. The walks plus hits per inning pitched, WHIP, records the bases on balls, walks, plus hits divided by innings pitched. It's a good way to measure the approximate number of walks and hits a pitcher allows in each inning that he pitches. It then compares that amount to other pitchers to formulate a pitcher's index.
Why is Omar Khayyam so famous?
Omar Khayyam is not as well known for his contributions to math as he is for being immortalized by Edward Fitzgerald, the 19th century English poet who translated Khayyam's own 600 short, 4-line poems in the Rubaiyat. However, Fitzgerald's translations were not exact, and most scholars agree that Khayyam did not write the line "a jug of wine, a loaf of bread, and thou." Those words were actually conceived by Fitzgerald. Interestingly enough, versions of the forms and verses used in the Rubaiyat existed in Persian literature long before Khayyam, and only about 120 verses can be attributed to him directly.
What is the atomic formula of predicate calculus?
The atomic formula of predicate calculus is when a predicate and special case of a subject, individual, are written together. For example, if M is the predicate to be a human, and B is the subject. Individual, Socrates, then MB means the assertion Socrates is a human. This atomic formula is phrased B is the argument of M. Thus, M, as the predicate, may be applied to any subject, and that subject is then an argument of M. But if C is the subject Vermont, then MC is a false assertion, because Vermont is not a human. Some predicates require more than one argument, thus, you can have formulas such as MXY.